Yo, what's up guys? Welcome back. It's KongBoy. And in this video, I'll be explaining zero-knowledge proofs and why they're going to change the future of privacy. Have you ever wondered why we give out our social security number to people, even though that's technically all they would need to steal our identity? Well, this is one of many problems that zero-knowledge proofs could help solve. First, I'm going to give you a basic understanding of how they work and then dive deep into some examples of what they could help with. Zero-knowledge proofs use math and cryptography to prove that some information is true without revealing the details of that information that make it true. They let private data be used in transparent operations where the logic behind this is public. A commonly used example to explain how they work is "Where's Waldo?" So imagine someone asks you to prove that you know Waldo's location, but you don't want to reveal his exact location relative to everything else because that would give it away. So you could take a picture and crop out Waldo without showing what's around him. This is especially useful for blockchains since all their information is public by default. So if we want to expand its use cases into areas that involve privacy, then this is going to be extremely useful. The concept of zero-knowledge proofs was first described by researchers at MIT in 1985. But it was first implemented into ZCash in 2016. ZCash is a fork of Bitcoin, which means it's a copy of its code with a few changes that allow users to transfer tokens privately on the network. These private transactions are shielded using zero-knowledge proofs, and the contents of the transactions are proven to be valid using the cryptography behind the ZK proofs. So Zcash is a blockchain specifically designed for privacy, but the same thing can be achieved using applications on blockchains that were not built with privacy in mind, using something like Tornado Cash. ZK proofs have plenty of potential use cases outside of blockchain, one of them being financial. So let's say you want to log into your bank, and instead of using information like what street you grew up on, your mother's maiden name, or your pet's name, you could use a zero-knowledge proof in order to log into your bank account. Or we could prove that someone's credit score is above a certain threshold without revealing the exact value of it. Some other areas where zero-knowledge proofs could be very helpful would be in verifying government clearance, social networking, and messaging, as well as gaming, which we've seen in Dark Forest, which the game mechanics allow for player locations to be hidden, and planet locations, which is the goal of the game, to collect resources, those locations to be hidden. One big area where zero-knowledge proofs would be extremely helpful is in identity solutions. I already mentioned how social security numbers basically act like our real-life private keys, and yet we give them out almost all the time. ZK proofs can allow for digital IDs that have encrypted information about aspects of someone's identity that would be useful to have private, or just about anything. ZK proofs would let someone prove some specific piece of information about their identity without revealing any details. Here's a quick and easy example. A ZK-backed ID could allow you to prove that you're of a certain age without revealing your date of birth, or even your approximate age, because they would use a ZK function to generate and verify a cryptographic hash using the information on that ID when it's requested. And since this ZK proof digital ID would be based on a smart contract that you have control over, this would avoid any sketchy things like somebody requesting and getting an answer to whether your age is above 21, below 25, and then just narrowing it down from there to figure out what your exact age is. Also, no one would be able to run a non-consensual check on this ID since you have control over the contract and would have to sign with your wallet in order to provide proof to a given request. There currently are teams working on this type of identity solution, but this theoretical perfect ID would have some user interface and functions that would translate the smart contract code into plain text in order to figure out what you're actually sending the proof for. Zero-knowledge proofs are also used for layer 2 rollups, commonly done on Ethereum, in order to prove that the computation done on this layer 2 chain is correct, without the base chain or the main chain having to run all that computation on its own. Otherwise, it would be pretty pointless. This means that ZK proofs could allow for verifiable computation to be done on these networks that have faster and cheaper transactions, but also benefit from the security of Ethereum. It's still very early in the research and development of zero-knowledge proofs, and even just a few years ago, the founder of Ethereum, Vitalik Buterin, called it moon math. So there's a lot to look forward to and a ton of potential use cases for this technology that involve privacy and scalability for blockchains. Once zero-knowledge proofs take over the world, we can finally stop using social security numbers. And check out this meme.